In this section, from here onwards, we shall only have the integer value type of answers that will be coming for the question following. So let's take on the question number 21. In question number 21, 3 moles of a monoatomic gas undergoes through a cyclic process A, B, C, A as shown in figure. The temperature at B and C are 500 Kelvin and 1000 Kelvin respectively. If work done on the gas in process CA is 22,500 Joule, then net heat released by the gas in cyclic process is to be taken in kilojoule. Take the value of R is equal to 25/3 Joule per mole per Kelvin. Fine. We shall be starting with the first law of thermodynamics, that is delta Q would be delta U plus delta W with the standard symbols here. For the cyclic process, if we start from A, then A to B to C, and then again from C to A, the total change in internal energy would be 0. That means delta Q must be equal to delta W here. So delta Q, I would say, from A to B, delta W is 0. From B to C, it is a perfectly isobaric process. So I would say it is nRdt, n being 3, R to be taken as 25/3, and it is 500. Now, from C to A, it's been said that the work done on the gas in process CA is 22,500 Joule. This is work done on the gas, so delta W should be negative. So I would say it is 22,500 in SI unit. Fine. Now the value is coming out to be minus of 10,000 Joule. So this delta Q is actually the heat given to the system that is coming out to be negative. So I would say in complete cyclic process, the total heat rejected by the system is actually 10 kilojoule. So 10 kilojoule is the heat rejected in this process. 10 is the final answer for our question number 21. Now we shall proceed to next question. In question number 22, the figure shows a tube having a sound source at one end and an observer at the other end. The source produces sound of frequency up to 5000 Hz. If speed of sound is 300 meter per second, then the maximum frequency for which observer hears maximum intensity is n into 100 Hz. Find the value of n. If the constructive interference will happen, then only the observer at this end would hear the maximum intensity. I would say the wavelength for the given frequency, it would be how much? It is 300 divided by f. Fine. The wave that is coming from here will be bifurcated in this direction and this direction, and the wave that is actually coming from this direction shall have an extra lead of 20 centimeter of path with respect to this wave. So the path difference will be how much? 20 centimeter. I'm saying this part to be 20 divided by this much in meter. So now let's say the constructive interference is happening. So it must satisfy the equation that delta x must be equal to how much? N lambda. So it is 20 divided by 100 must be equal to n into 300 divided by f, or f will be getting this value as 300 into 100 divided by 20. It is n into 1500. So changing the value of n, for n is equal to 1 here we'll be getting 1500. For n is equal to 2 we'll be getting 3000. For n is equal to 3 we'll be getting 4500, and further on. But it's been given that maximum frequency that actually being produced is 5000 Hz only. So of all these possible combinations, we are having 4500 Hz will be the maximum frequency for which the person will be hearing the maximum intensity. So the value of n, it will be how much? 45. That's the answer for question number 22. Now let's proceed to question number 23. In question number 23, a spherical cell has inner radius r and outer radius 3r and thermal conductivity K. The inner surface is maintained at a constant temperature of 3 T0 and surrounding temperature outside the cell is T0. The rate of radial flow of heat through the cell is lambda into pi K R T0. Find the value of lambda. We'll try to calculate the thermal resistance of this much of the system there. So I would say let small resistance at distance x from the central point, it will be dr, then it must be equal to 1 by k dx divided by 4 pi x square. Now integrate this portion from x is equal to r to 3r. So r effective, it will be coming out to be as 4 pi k integral of dx divided by x square from r to 3r. So this portion, effective resistance, this will be how much it is? 1 by 4 pi k into 2 by 3r. Now, radial flow of heat energy, that will be delta Q by delta T. It is total temperature difference, that is 3T0 minus T0, it is 2T0 divided by effective thermal resistance, that is 2 into 12 pi kr. So this one will cancel out and we are having this value delta Q by delta T is 12 into pi k r T0. Got it? So comparing this answer with the one given here in the question, we are getting the value of lambda to be equal to 12. So that's the answer for question number 23. Now let's proceed to question number 24. In question number 24, in a cylindrical vessel, two immiscible liquids are filled as shown in figure. A small hole is made in side wall such that effluxed liquid hits the ground at maximum range. The maximum range is kh. Find the value of k. I would proceed with the calculation that if the hole is being made at this point here such that the liquid of density rho will be coming out from here, then it will have the maximum range. So how much the velocity it would be? Root 2 into g into 4h. This will be the velocity of the efflux. And by the time it will leave here, it will fall to the ground. So this time from here to here, it will be 1 by 2 gt square will be equal to 4 into h, or we'll be getting the value of t to be equal to 8h divided by g square root. So the range will be how much? This r, it is r is equal to v into t, or 2g into 4h into 8h divided by g. This one will cancel out. It is coming out to be 8 into h. Fine. So here the value of k we are getting, that is 8. That's the answer for question number 24. Now let's proceed to the final question of this paper, question number 25. Question number 25. Two tuning forks A and B vibrating together produce 4 beats per second. Frequency of B is 512 Hz. It is observed that if one arm of A is filed, the number of beats increases. Frequency of A before filing is 500 plus n Hz. Find the value of n. It's been given that the frequency of B, it is 512 Hz and it produces 4 beats per second with A. So the possible frequency would have been, it is 508 or 516 Hz, either of these two. Now, another statement that actually been given, it is when A is filed, the beat frequency increases. It simply means when the frequency of A increases, the beat frequency or the difference of frequency with B increases. So if I would say the frequency would have been 508, and if it increases to 509, then we see that the difference is decreasing. So definitely on the same argument, I would say that initially the frequency of A must be 516 Hz. So we are getting the frequency of A to be equal to 516 Hz. So looking onto the question that actually been given here, it is 500 plus n. So I would say the value of n is equal to 16. That's the answer for question number 25. That's the end of this question paper. Hope you must have understood the solution properly. I wish you all the best for your further preparation. Thank you and goodbye.